right, sweet kiddos, we're going to get going on this. I'm not sure how well it's going to work. I've ordered a stylus, but I do not have it in at the moment. And so that kind of causes me a little bit of a problem when it comes to writing, because I have to use my finger and it looks kind of like this. And I can't get it very small and I can't get it very accurate. So be patient with me. I've ordered a stylus that goes specifically with this tablet that's supposed to write nicely, and we'll hope that that will end up working, maybe, hopefully. For right now, as we go through, be sure you pause whenever you need to and jot down notes, jot down questions, things that you can ask the next day in class. We're going to try this because I'm concerned because we're running out of time to get everything covered. So at this point, again, please be patient. Jot down a ton of notes. Expect a quiz when you come back in to make sure that you've been listening to things. And so make sure that you listen to the recording. Expect, what was the answer to example number 2 or something like that. What formulas did we talk about? What examples do we have? All of that type of thing. So for right now, let's get started, see where this takes us. All right, here we go. Section 4.2, product rule. Section 4.3, quotient rule. You already knew that. We're going to spend a couple of days on this, making sure that we've got it all down. We want to find the derivatives of functions that involve products of functions or quotients of functions. Our whole goal is to get where we can do products and quotients really well. The first thing we're going to do is look at the proof of these two rules by the definition of derivative. Now, when I go to those pages, you're going to need to pause this and write it down and see if you can figure out, there's two things. You need to figure out what in the world's going on and where I got the stuff. And then number 2, you need to figure out the last line, because the last line is not showing in either one of these. Hopefully when I say by the definition of derivative, your brain is immediately going to the limit definition as h goes to 0, because that's where it needs to be. So the first thing we'll look at is our proof of the product rule by the definition of derivative. You can see that limit as h goes to 0 there. Your function f of x is defined as g of x times h of x, and so therefore I have written down this proof. Jot it down in your notes. See if you can figure out what in the world I did, because it takes a little bit of creativity to come up with this. And then notice that the last line is not there, and so you need to do an equal and come up with whatever should be written down on that last line. I want to see tomorrow in class what your ideas are. It's not that this is going to be necessarily on that quiz, but I definitely want to hear your ideas and your thoughts on this. See if you can figure out how we worked it. Next one's the quotient rule. Again, same concept. This has some of that critical algebra in it that you've got to be sure you understand to be able to make these problems work. And then again, you are missing the last line, so be sure you tell me what it really equals down here. Okay, pause these as you need to. Scoot your the video thing back and forth so you can get it all copied down. And then when you're ready, let's move on and work some problems. Okay, we're going to start with example number 1 here. I know there's 2 examples here, but writing with my finger, they're not obviously going to fit on this one screen, so I've copied the page, and the next one we'll try to squeeze the second one in. Hopefully we can get them into enough room. Again, it's going to be pretty messy, so be patient with me and let me know when we get back into class if you just absolutely could not read something and you need some work to be able to get it down and understood. All right, so first one, f of x equals x cubed cosine x. Remember that that means that f of prime of x, not much of an x, be patient, write your x down, equals your first times the derivative of the second. Now derivative of cosine, remember, is negative sign. Derivative of any co-function is going to always be negative. So the derivative of cosine is negative sine plus the second, which is cosine x, times the derivative of the first, which is 3x squared. Okay, Okay, again, anytime you need to pause, pause, jot things down, but you're probably ahead of me at this point since I am writing with my pinky. Okay, equals, simplify this, pull that negative out front. So you have negative x cubed sine x plus 3x squared cosine x. And that's it. That's all there is to that one. The next one's going to be slightly more challenging, not anything big, but it does happen if you notice in that second term there that you're multiplying times x to the 7th. You're going to have to do your chain rule. So this is going to be a product rule and a chain rule problem. Okay, here's our blank page for this one, so let's go with it. Y prime equals, your first is x to the 7th. Times the derivative of the second. We're going to need a bracket on this one, and that's going to be 10 times 2x plus 5 to the 9th times 2. Okay, now all that is, that's first times derivative of the second. We still have to do plus the second, 2x plus 5 to the 10th, times the first, derivative of the first, excuse me, 7x to the 6th. Okay, so first times the derivative of the second plus the second times the derivative of the first. Combining like terms, we've got y prime equals, on the first term we're going to multiply our 2 times our 10, so that's going to give us a 20. Oh my goodness, I'm not sure what happened there, y'all, so sorry. See if I can get part of that erased. Okay, all right, somewhat better maybe. And let me make sure that I'm still writing with the little thin line. Yes. Okay, so 20 x to the 7th times 2x plus 5 to the 9th. And then plus, and there's not enough room for me to do this, so I'm going to go right down beneath it, 7x to the 6th times 2x plus 5 to the 10th. Okay, now then your problem with leaving this like this is that it's not as neat as what we want it to be. We still want to be able to factor things out. There's an x to the 6th in each term. There is a 2x plus 5 to the 9th in each term. Those need to come out. So you'll need to pull out x to the 6th times 2x plus 5 to the 9th. Remember, you always factor out the lowest exponent value. And that will leave you with 20x plus, oh, I'm still out of room, 7 times 2x plus 5. Okay, the x to the 6th is out in the front, and the 2x plus 5 to the 9th is out to the front, so you have a 7 times a 2x plus 5. So let me go ahead and multiply that through and show you that that is 14x plus 35. Okay, so one last step, we're going to write all this in one fell swoop here. So I have 7x to the 6th times 2x plus 5 to the 9th times 34x plus 35. And yes, my pinky is cramping from writing with it. But there you go. There is your answer on that one. Every time that you'll do these, you want to look for what you can pull out to the front so that it'll be completely simplified. All right, moving on. Okay, I have cosine cubed x over natural log x. So f prime of x. Oh, let me get my pen. Excuse me. F prime of x is going to equal bottom times the derivative of the top. This is going to be a little harder for us to write, so y'all hold on and be really patient. So this is going to be 3 times cosine squared x. Okay, I may not be able to do this one at all. Times sine squared x. See if I make this bigger, if I can get anything done at all. Okay, patient with me. Let me kind of erase here. Whoa, not sure what happened there. So sorry. Okay, I can make this bigger, but it may end up backfiring on me. We will give it a shot anyway. Okay, so try one more time here, and we've got f prime of x equals the bottom times the derivative of the top which is going to be 3 cosine squared x sine x, right? Or negative sine x, excuse me. Okay, because that's cosine x cubed, so you got to do your chain rule. 3 cosine squared x times negative sine x. Okay. Remember that this is all going to end up being over your bottom squared, since I am not with very much room here. Sorry, that's natural log of x squared, okay, minus bottom times the top minus the top cosine cubed x times the derivative of the bottom, which is 1 over x, all over natural log x squared. Okay, so that at the moment I had to write it with a common denominator, I mean with separated things, but know that it is a common denominator. All right, on the top there, my problem is that I can't leave a fraction within a fraction. So that means I need to multiply the first one times x on the top and the bottom in order to get rid of this. So all the way through the entire top I'm multiplying by x, and all the way through the entire bottom I am multiplying by x in order to get rid of that 1 over x that's there. So this equals, I have a negative from the sine and a 3 from the cosine squared, and then that x that I am multiplying through right there. So that is negative 3x natural log x cosine squared sine x. Okay, is everybody good with that? Multiply it all the way through the top, and it'll end up, it's going all the way through the entire top, so it goes through both terms on the top. It's now gone through the first part of the fraction, okay, minus, when it goes through the second part of the fraction, it cancels with the 1 over x. So I'm left right there with just cosine cubed x. All of that over, we multiplied the bottom times x also, natural log x squared. Okay. On that one right there, you could factor out the cosine squared x, but it's really not going to be all that beneficial to you. It doesn't allow any terms to shrink down nicely or anything like that. So really and truly, There you go. Okay, going back through it one more time, you had the bottom natural log x times the derivative of the top, 3 cosine squared x times negative sine x, minus the top, cosine cubed x, times the derivative of the bottom, 1 over x, all over the bottom squared. Then all we did from there was multiply the top and the bottom all the way through by x, distributed it to both fractions, and that's where we end up with this answer. If you have any questions on that one, because it's pretty rough, please let me know. All right, last one, and it's kind of messy, so it may take us a little bit to get through it, but again, just be patient. Here we go. All right, so y prime. Oh, and I have no pen. All right, see if we can finish up here. Y prime. Oh, there it comes. Y prime equals bottom 5x minus 2 to the ninth. Remember, the bottom does not change. It's very important which one you subtract on this. So low D high, right? Bottom times the derivative of the top. That's going to be 6 times 8x plus 1 to the fifth times 8 by the chain rule. Again, we're going to have to do these in two separate fractions, so be sure that you know that in the denominator you have 5x minus 2, because that bottom has to be squared, to the ninth squared. Remember, power to power you multiply, so that's got to be to the 18th, doesn't it? Kind of an 18 there. So bottom times the derivative of the top, minus the top, 8x plus 1 to the sixth, times the derivative of the bottom, 9 times 5x minus 2 to the 8th times a 5 by the chain rule. Over that bottom squared. Okay, now this one has a lot of thought going into it, so let's kind of keep it rolling here. We've got an 8 and a 6 in the beginning that's going to pull out, so we have 48 times 5x minus 2 to the ninth times 8x plus 1 to the fifth. And then we are going to run completely out of room, so let me go ahead and put this over my 5x minus 2 to the 18th. And remember, we're subtracting, pulling the same things out on that next one. I've got a 5 times 9, so 45. And 8x plus 1 to the sixth times 5x minus 2 to the 8th. All over 5x minus 2 to the 18th. Okay, pause 1 second here. All right, I've added a page in so we can keep going. So when you look at this, everything's got the same common denominator, but they also have some other things in common. They've got 5x minus 2's and 8x plus 1's in common. Remember, pull out the lowest exponent value. Don't worry about 48 and 45 at the moment having something in common. Did I put a 6? Oh, that's 8x plus 1 is 6. Excuse me. Don't worry about them having something in common, because we'll get to that in just a minute. So, equals. Okay. We're going to pull out 5x minus 2 to the 8th. We're going to pull out 8x plus 1 to the 5th. And that is going to leave us with a 48 times, we have an extra 5x minus 2 right there, plus, minus, and forgive me for, this is very poor notation, but give me the break just this one time, minus 45 times what I have left there is a 5x and 8x plus 1, excuse me. All right, so that gives me everything that I have left over, and remember that all of this, again, poor notation, 5x minus 2 to the 18th. Okay, so let's kind of get this simplified and make this as easy as possible. My 5x minus 2 to the 8th, I'm going to write, just because my notation is bad, I'm going to write it one more time, and then we'll cancel it with the ones on the bottom, times 8x plus 1 to the 5th. Okay, times, and then on this next one, when you distribute through, 48 times 5 is 240x. 45 times 8, 5 times 8 is 40, carry your 4, 32, 360x. Okay, and so 48 times 5x, 45 times 8x, you have 120x there, I believe, negative 120. I am erasing for some reason. Give me 1 second. Okay. Okay, so there's my parentheses. Sorry, y'all. 120, negative 120x. And negative 96 minus 45. And negative 96 minus 45. Sorry, y'all. Had to pause for just a second there. You get negative. Okay, there. I'm going to write negative 96 and 45, negative 141, I believe. And if that's not right, y'all correct me tomorrow in class. All over 5x minus 2 to the 18th. Not sure where that extra little bar came from there, but that's 5x minus 2 to the 18th. I have an 8 on top, 18 on the bottom. Y'all are having to be incredibly patient with this at the moment. So all of my 5x minus 2's cancel out on the top. I am left with 8x plus 1 to the 5th times negative 120 x minus 141. That does not look like a 4 or, okay, I think that's a little bit better. All over, maybe, there we go, 5x minus 2, and it just insists on putting that line. That is not a 15, that's 5x minus 2. And the 8 and the 18 cancel, so I'm left with a 10. Okay, so again, seeing if I can just kind of correct this just a little bit right there. That should not be there. There should be a parentheses, but there should not be anything that looks like a 15 at all. So hopefully that is close and you can tell what we're doing from that. And there is the homework that we will be doing. You do not have to do it right now. We will be working on it together in class, along with clearing up any questions or problems from this other. Again, thank you for being very patient, and hopefully that stylus will be in sometime this week and these will get better. So, all right, y'all have a good night. Bye.